Alright, welcome back. Don't forget to smash like and subscribe as always. We're just going to pick up where we left off here on PLC IOSim. We're on challenge number 7 out of 24. And yeah, garage door number 2. Let's go. Medium difficulty. So it wants us to design a program to control a garage door, same as before. But this time, pressing normally open button momentarily energizes the motor contactor in the forward direction until the door reaches the normally open limit switch for the up position. Pressing the normally open close push button momentarily energizes the motor contactor reverse until the door reaches the normally open down position. Pressing the normally closed stop button at any time stops the operation. Additionally, instructions, forward and reverse, are programmatically interlocked so that they cannot be energized simultaneously. Alright, let's see if we can figure this one out. To start, we're going to make 2 start-stop stations. The same one we made before, I forget which challenge it was, but it was in the first video, where we made the start-stop station with a holding contact. And, one's going to be for forwards, and one's going to be for reverse. So I'll just make those quickly. Okay, we'll make this bottom one the reverse contactor coil, and the top one the forward coil. And this is actually going to be the stop button for both of them. And basically, we'll need the normally open push button to go for forward. So open. Normally open close push button for close. We're going to need to make our holding contacts so that when we let go of the button, the motor doesn't stop. And then we also need to add the high and low limit switches. So the up limit switch is normally open and will turn off this forward motor. So when you get to the top, the switch will close. So what that means is performing the same function as the stop button. We need a normally closed contact that will open up when we reach the top. Same thing down here. Normally closed contact that will open up when we reach the bottom. And I think that should work. I think there's one more thing. We need to make interlocking so that the forward and reverse cannot be energized at the same time. So again, this is something we've already covered in a previous challenge, so nothing too tricky. We'll simply take the normally closed contact for the forward command and we'll put it in series with the reverse command. And we'll do the same thing up here, the normally closed contact of the reverse command. That way when this reverse is energized, this coil will open up, making forwards impossible. Alright, let's see if this is going to work. We're in run mode here. First thing we're going to do is momentarily press this open button that will energize this contact and therefore energize the forward command, which will in turn energize this holding contact. So when we release the button, we still have a path to keep it going. You can see the door opens. When it gets to the top, this up position switch will change states and the forward action will stop. So we'll do the same thing for closing the door. You can see the holding contact there. And when we get to the bottom, the down position switch changes states and the reverse turns off. Let's just quickly test the stop button here. Yep, a momentary pressing of the stop button is just leaving the door where it is, so that's good. Now the only thing we have to test is the interlocking, so that when we're closing we're not able to open, and that when we're opening, we're not able to close. And that way we're not trying to get the motor to spin two ways at once. Awesome. Looks like did a good job there. So yeah, let's just move on to number 8. Okay, for this challenge, it wants us to design a program to count the number of times a push button is pressed. Pressing button number 1 should increment the counter. Once the counter is done, lamp 1 should energize, and pressing button number 2 should reset the counter. Cool. So you can see they've made the counter for us in the variables table here, labeled it counter 1. So we'll go to counters here, and we'll use a CTU. That means count up, I believe. And we'll reference it to counter 1. Now, counter.acc is the accumulation. So every time you enable the counter, the ACC will go up by 1 value. So we can do that by adding a contact here that feeds the counter. If we reference that to push button number 1, we'll see that the ACC will go up when we press push button number 1 and release it. So you can see we can keep counting past our preset value of 3. We're up to 11 here. So we're going to need a way to reset the counter. So I'll make a new line, and we'll add push button number 2 for reset. And they actually have a command here, reset, that you could just reference to counter 1. And this way, when you click on push button number 2, the ACC goes back to 0. So there's also this done bit, that's the DN. So once the ACC is equal to or greater than the preset value that you select, then the done bit will turn from a 0 to a 1. Watch this. 1, 2, 3. This done bit turned into a 1. So what we can do there then is add a new line, a new contact, reference it to the done bit, counter1.dn, and have that feeding the lamp. That way when the counter is done, the lamp will turn on, which it's on right now, so let's reset it. So once we click the push button number 1 3 times, the counter finishes, the lamp turns on. And you can reset it with push button number 2. There you have it, folks. Let's go on to the next challenge. I believe we're already up to challenge number 9 here. Basic on delay timer. Alright. Design a program to control a lamp with an on delay. Pressing the button number 1 should energize the timer, and when the timer finishes, the lamp should turn on. Okay, so similar to the counter we did, they made a timer for us in the variables, timer 1. So we'll just go ahead and find that. We'll do a T on, that means on delay. T off would be off delay. I'm going to call it a ton. So we'll call it timer 1. You can see they've preset it to 3000. And I believe it's pretty standard that these units would be in milliseconds. So this actually means they've preset it to 3 seconds. So how that works is once you enable the timer, it won't make the output on until after 3 seconds pass. So we'll need a way to enable the timer. So we'll just find a contact and call it push button 1. And we'll just basically, in order to turn on the lamp, we'll need to add another contact, which will be equal to timer1.done, dn. So when you click push button 1, 3 seconds later, the timer will be finished. It will activate its done bit, and that lamp should turn on. So let's give it a test. 1, 2, 3, bang. Beautiful, it works. And the thing about on delay timers is if you turn off the input here, the output will turn off no matter what. So it's basically self-resetting in that regard. So if I press push button 1 and release it before the timer expires, the output will just stay off indefinitely. It can only be counting while it has an input. So we'll just watch it one more time. Cool. Yeah, that's a basic on delay timer for you. Hope you guys are having as much fun as I am. All the way to challenge number 10. I think we should be able to do this quickly. Okay, so this one will be very similar to the on delay timer, but it's an introduction to off delay. So I'll just throw the timer right in there. Timer 1, T off. Now these timers work a little bit differently than on delay timers because they have an off delay instead. So we still need to set up our circuit the same way, our logic. So we'll need the done bit for timer1.done, and that will be feeding the lamp. However, I guess we still need the enable button. These timers work a bit differently. So when you press the when you enable the timer by giving it an input, the done bit will actually be on right away. So as long as the timer has an input, the output will be on, and the timer won't start until you release the input. So watch, I'll release the PB1 and the ACC will start counting all the way to 3000 milliseconds. And you can see once it gets to 3000 milliseconds, the done bit changes from a 1 to a 0 and the lamp turns off. So you can immediately turn the lamp on, and then when you flick it off, it takes 3 seconds. And you don't need a reset in this case because the timer will reset itself. So a little bit different than the on delay timer. Hope that makes sense. Nice simple introduction there. Okay, on to number 11. Wow, we're really blasting through these at a good speed. So, design a program using a retentive timer on delay to control lamp 1. Releasing PB1 should de-energize the timer instruction, but the lamp will stay on. Use PB2 to reset and turn off the lamp. So a retentive timer behaves a little bit differently. So we'll still set it up with our push button 1 because the timer still needs an input. Do RTO, retentive timer on delay, I guess. Reference it to timer 1, which they set up. And so I'll show you how this works. If we set it up the same way as we did before, if we put the timer done bit here, and that controls the lamp, and we get our reset button controlling the reset for timer 1, and just hit run. We'll see what happens when we press PB1. Then it will start counting to 3000 immediately, and once it does, once the ACC reaches the preset, the done bit will turn on and the lamp will turn on. But with the regular on delay timer, when you release the push button for the input, the done bit would go to a 0. But you see, in this case, the done bit will stay on even though the timer doesn't have an input. So that's why we have this reset button. And there's more than that to it. So I'll just momentarily press PB1. And you can see PB1 was pressed for 329 milliseconds. So basically this timer will only count when it has an input, but when you release the input, it will remember whichever state it's in and hold. So yeah, you can reset it at any time. So it's a bit different than the regular on delay timer. You can see how that would be useful if you wanted to time something retentatively, if you know what I mean. Alright, that's all the time we have for today, but yeah, we'll pick up on number 12 in the next video, halfway there to the end, number 24. Alright, smash like, subscribe, and have a nice day.